Hello, welcome back to my shop. If this is your first time here, welcome. And don't forget to hit that subscribe button and the little bell so you know when I do more of this stuff. Today we have a Crown Comtech 200. 200 watt amplifier, about 100 watts on each channel. It has inputs on the back here, show you a picture. It also has attenuators, not volume controls, but attenuators for lowering the input and not for raising it. That's kind of interesting. And it also has outputs over here for the two channels that come into it. One of the ways it does it is 8 ohms or 4 ohms, I believe, or 8 ohms. And it also does 70 volts for the old 70 volt system. I got this in from a radio station. He said that it's not working. The lights in the front flash every once in a while and the speakers go pop. I'm not even going to plug it in because it's an amplifier. And we all know things can go drastically wrong if you just plug them in and try them. So I got the screws out on the side. Let's take a look and see what's in this thing. I've never been in one of these. I've done some Crown 60s and some other stuff, but this is the first one of these I've seen. So take the top off. There's only 4 screws holding the top in. And there we go. So what do we got? Ta-da! Well, not much from here. We have big old transformer. This is the output connection board back here. That doesn't appear to be a lot on it. It plugs in. We've got evidently our outputs. And what do they got? What are the transistors on this? Let's see. 2SC 8188-2s over here. 2SD 6729s. It appears one of them has already been replaced. Well, nice heat sinks, nice radiators. And this one is the same thing, only flipped around the other way. 8188s and 6729s. Big old giant capacitor. 2 of them. Let's see. Board with bunch of those little opto isolators on it. At least they're 6-pin packages. I presume that's what they are. And a relay. Little relay. Some big resistors. It appears that this board drives the LED output up here. The LED outputs, it's got ODEP, IOC, and SPI, and an enable light, and an on-off switch. And that's it. That's all that's on the front. You can turn it on, you can turn it off, and you can watch some stuff. It also appears to have room for doubling up of these transistors. So evidently they use this same thing for 400, 800, or I think there's a 1600 version of this. This is the little guy. What are these guys over here? They look like, I don't know, what are they? Ugh. Can't see them. The lights. 2SA 1186. Yeah, 2SA 1186s. I don't know. Little stand-up heat sink going down into the main board in the bottom. I guess there's a main board in the bottom of this on each one of these. And there appears to be a big board down here in the bottom. Got a couple of... These are the switches back here to switch between 70 volts and 8 ohms or 4 ohms. Looks very, very well built. Well, it's a crown. These things are built like bricks. I've got one of my old stations that's been running literally forever. I've had to repair it a couple of times, but it was all minor stuff. You know, one of the transistors went out or something. That's about all there is on the top. Let's take the bottom off and see what it is. This thing, you might be able to guess, is fairly healthy weight-wise. Let's see. The top, or the bottom of it also just appears to have 4 screws to take it apart. It's quite healthy weight-wise. Okay, yep, there's just 4 more screws. That's it. Wow, that's not much holding it together. I'm kind of used to this radio station stuff. It's 97 screws holding on the top because of RFI. And they don't want it to get in, so they seal them up. This one, well, it's a big old power amp. I don't think a little bit of RF's going to hurt it much. Yep. Oh, what's this? Oh, okay. Comes up. The filter comes out with it. I gotta give these guys credit. I mean, that filter is clean. Somebody's vacuuming this. All right. Good for you. Wow. Okay. Whew. We have a big pile of stuff in here. A lot more than I actually expected for a simple little amplifier. Goodness. So what is it? Well, these are our main output boards, I'm sure. Big old power leads going to them. What is this? Bothers me when I see a wire running across the board. It says revision A. Maybe that's a... Oh, there's another one on this. They're backwards. Yeah. This one is facing this direction. This one's facing this direction. And this is the input board, I guess. I did get a schematic for this. It's hard to read because it's a horrible copy. But I've got one. Interesting. It's the screws over on this side of the board, here, they look rusted. That's not entirely good. I'm not even going to test the transistors or nothing yet. We're just going to take this apart and look at it. Anyhow, a little bit of work back here, seems, and some stuff over here, at least. Or maybe that's from factory. I doubt it. Is that a bad... No, this is... I thought it looked like a bad connection back there, but it's not. I got a couple other more transistors back here. I don't know. We'll look at the schematic in a little bit, but I guess let's take this thing off and see what it is. It's big. That is a lot of board for just a PA amplifier. Or, well, they use this thing to put audio into from the station audio up into the meeting rooms and things, I guess. They must really like their audio because, wow, that's a lot. It's got little standoffs here. and little standoffs here. I guess, okay, so it's got these guys. It's got these little plastic standoffs, like you see in computers, on the bottom of this board to keep it, I guess, from hitting the bottom of the case. Okay, why not? But it also has a couple of them down here. All right, little squeezy guys. There. There we go. Oh, there's a couple of those knobs fell off. And here's this thing. Ooh. Wow. That's quite a bit of stuff. What is that switch for? Z1, Z2, Z3. I don't know. What does it say on the back? Oh, this is for parallel mono, bridging mode, and dual. So, this is on dual. So, individual channels, individual controls. That kind of makes sense, you know, if they're going to use it for different rooms. Come on. And, well, ooh, eee. Wow, look at this. That does not look good. Bring you down here. What happened here? Quit moving. That's not good at all. Oh, looky back here. Look at that. I think, because this is right above here. A couple of transistors and some resistors and all coated with soot. But this right here, D8, is fried. I mean, just cooked, broken. So that would be, let's see, backwards. So that would be the same as over here, right there, which is DO5. DO7, yeah, DO7 and DO8, so they're not numbered the same, but that would be that same part as is right here, but back on this side. Wow, that's interesting. Let's okay, I'm going to say offhand, let's just put a little on here, scrub this off, and yeah, that got hot, but yeah, they don't appear to be burnt. Okay, I just think that that's burn up detritus from that thing going kerpoof. Wow. Okay, well, I guess we got to look on the manual and see what that is. That is on the, no, that's an O, not an, so this is the 7, okay, DO7, DO5, okay. So these are identical boards, but this one just, there's a hole in there. So that one actually literally caught fire. Wow. All right. Well, let me get the manual up here. and see what we got. Manual. Okay, so what is it? Here's the input. Comes around and goes down to crown. Man, the schematics are a little weird. They don't always go in the right direction that you're used to. You know, from like input to output. These guys go input, back out here, to output. You can't see my pointer, of course, but and then back into this side. So I guess this whole board around the outside is this, and the dotted line here, right here, that would be these guys. They only show one side of it. So, I guess. Let's go on into the manual a little bit. Yeah, so there's your balanced, unbalanced input stage, which is that little board on the top. It does have some active components on it. We'll look at that later. And here's your output board. So what do we got? I mean, it's in the NPN section. It says, whatever that means. These are 300 numbers. 307, 300A, 5. Like I said, this thing's kind of hard to read, and it's the best one I could find. Both ends of these go to chassis ground. No, they don't. Both ends of these go to VCC for the cathode, and the anodes go to minus. No, they do not. The cathodes, one goes to minus VCC, and the other one goes to one end of this RO4. Okay. So, yeah. RO04, 304, and 307. That's going to be right here. Okay. All right. So, I think our problem with what's burnt up completely is this D307 right there. Okay, well, break them loose, or try to. There, that one's good. One's good. All right, well, this thing, how tight are these guys? Probably very. Oh, yeah, that's on there. Do they indeed come out? Yep, they do. All right. Just checking to see what these actually are holding down here and how big they are. And yeah, that's it. You know, this is silly. I'm gonna do this. Big screws. These go right into the heatsink on the other side. This rustiness on these bothers me. I don't like that at all. I mean, this thing's supposed to have been sitting in a rack room somewhere. When was the rack suspended in water? And this doesn't come from near the sea. This comes from the middle of the country. And I would not expect there to be this much corrosion. I definitely want to make sure this thing didn't go anywhere. Sure, it's for heat. Alright, so are you screwed down? No, you're not screwed down. You're just well, like I said, it looks like double-sided sticky tape here holding this thing on. Or something. Those guys are loose. Those guys are not. Yeah. Let's clear them out a little bit more. I didn't quite get that. Didn't at all. You loose now. Yes. Something else holding it down. Feels like that. But there's nothing there. This transistor does not. What is that? A13068. Not a clue. Unless this is... Is that screwed down from the other side? No. It can't be. And that... I don't think so. I just think that's little bitty short screws going through there. We're doing this together. Like I said, I've never worked on one of these. Does that help? No. Ah. I see. He said. Dummy. One thing's for darn sure, we got to get this out of here. This is not going to function this way. These guys have got to come off also. These big old transistors on the other side. Let's see. 1, 2, 3, 1, 2, 3. Of course they do, dummy. She. I just forgot all about them being there. You know, a lot of solder. I mean, a lot of solder. With all this corrosion down here, I wonder if those pots are any good even. I mean, it's... Whew. This might be one of those... Sorry, sir, but it's... She's dead, Jim. Is that... Did they glue this down? I can't believe they would have. Sure seems to be. I'm kind of careful about these. You don't want to break the leads off. Because some of this stuff, chances of finding replacements are... Wow, that thing is glued. I see it now. There's glue right there in that hole. That's a... Interesting. Now what? Oh, come on. There is nothing else here. Well, once we figure out what's holding this down, we might be able to figure out what's holding the other side down, because these guys, they're definitely loose. That's definitely loose. It's all revolving around this transistor. Okay. They fell out. Okay, well, something holding it in there. What is this? 3 wires marked EBC going up to something. Going up to something. Like what? Let's get this out of the way. Get you out of the way. Okay, so that would be right there. I don't know. Alright, so these guys go together and they go to the front. Alright, let's do a little bit more surgery on this thing, get it out of the way before I break something on it. Gotta cut that off of there. And that is a that's just a IC header. That's wimpy. And you. And you. Okay. And the ground, I guess. That's good enough. Okay. We gotta get these guys up. What is that? Bunch of glue. Glue in these. Yeah, it's also on this side, so I guess that's normal. Don't know about this. There's wires going through there. We'll have to see. So, okay, and then we need to get you detached from here also without burning the power wires. Come on. Thank you. And stand you up so I can get you past there. Did I get these? One of the reasons I'm taking this board out because there's a hole burnt right through the bottom of that thing, and I don't know what's on the other side of this. I presume this is single-sided, but that might be a stupid thing to assume. So I don't know. Okay. All right. So let's get this out of here now. I wonder if these screwdrivers or whatever they are, the schematic doesn't mark them as anything special. This one? Yep, right there. Alright, and these are 2837s. So they are different. Okay. Let's get these guys out. Okay. I just saw this little wire, these little wires here come down to a heat sensor. So, alright, you go with you, you go with you, okay. Isolated, separated so that they stay with each other where they're supposed to. Alright, next. Okay, there is no other heat sensor there. I still don't know what that... It must be mashed on the back of the board. This one, I think I can get it to go through. Might be able to get the little heat sensor to... Okay, so... phone call. Let's see if I can get away. I mean, this thing has two wires on it. They're both white. Never mind. I can take that off of there. It's just a temperature sensor. It doesn't actually matter. Yeah, this has been taken off before. Ooh, okay. There. All right. Now everything should be released. You would think. So now, take something a little bit bigger. What are you? I cannot see. It just goes straight across to whatever that is. And there's one down here too. All right, well. Take them loose. And take you loose. This all might be for naught. I don't know. I want to look at that real quick. Do they go across like the other ones do? Yeah. Ooh. That doesn't feel good. Feels like a really wimpy one. Alright. There's nothing holding this down anymore. There. Finally. Ew. Yeah. These things are hot snotted or some sort of serious glue down onto there. Yeah, look at that. Burnt right through it. Right through it. But there isn't. This is interesting to say the least. There's rust on the bottom of the board here a little bit. There is a pad. There's some sort of a metal pad, heatsink, I guess, underneath these glued down diodes. And these transistors are actually literally glued. Is that hot snot? Yeah, that's silicon or hot snot. I'm not sure which. Okay. I was going to say, why would they glue those down if you have to replace them? All right, well, I guess we can start taking some measurements. Let's, gonna have to fix that board somehow. I don't know how bad off it is. This thing comes off. Well, doesn't look absolutely horrible. Doesn't feel good. Yeah, none of the leads come through the bottom of this board at all. They're all kind of fake surface mount. Okay, that's interesting. Alright, well, let's do some testing. We'll start off with these guys. I'll bet you dollars to donuts that these things are bad. So 1, emitter, collector, base, 2, 3. I could do this with the... And verdict is, it's a transistor. Cool. That one's good. That one's good. That one's good. That one's good. Wow. Surprised me. Okay, on to the PNP side. Those I believe are all NPNs. Verdict is that one's good. That one's good. Okay, color me surprised. Okay, and these are the 2SC 1881s. Yeah, I could test these with a meter, but this is just about as fast. This is, okay, these are, there's a resistor of 0 ohms between 1 and 2. In other words, it's shorted. Let's see if the resistance goes between 1 and 3. Yeah, it's 0. Okay, so this 1881 is short, and I'll bet you the other one is too. No, it's a transistor. It's a PNP. Really? Yeah, it's good. So let us test this one again, just to be on the safe side. I'm sure it's bad. Yep, it is a piece of wire between 1 ground and I believe that's base. So ground, collector, and base. Let's look at this one again. So 1, 2, and 3. Okay, so collector is 1, of course, 2 is base, and 3 is emitter. Yeah, so this transistor over here had a base 1 and 2. Base collector short. Dead on short, base collector. Alright, but the rest of these are okay. I'm color me surprised. Seriously. And why? That was one either 03 or Q12? Either Q3 or Q10. Well, let's look at the meter at the manual again real quick. So we got 303 shorted through 304, took out 305. Yep, right here. So it went doink, 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 right down through here. I wonder if that 0.3 ohm resistor is still any good. Let's see. That would be U. .4. Yes. Okay, so get rid of the manual. Things have changed on this program. I got a new download, and it's not exactly the way it used to be. So here's our R303, R304 is 0.3 ohms, and here is the one. It's a complement R307. The other side is 0.3 ohms. So it didn't take out the sand block. Put this thing on diode. Okay. Check this thing. 0.5 volts. Point short. Yeah, point short. Yeah, this one is burnt, crispy. Okay, so I need a 2SC 8188-2. Get rid of all that. Hang on for a minute. Well, I did a little looking around, and I checked on eBay. Let's see if I can bring this up. YouTube, maybe? Yep, there it is. Wait. I can get 4 of them off eBay for $14.95 plus $4 in shipping. And it says that they're good. They're all good and pulled. There's no new ones. I saw another place it was $25 for one. So I guess gonna have to get that. I mean, they're nice and looks nice and clean, but yeah, you can see it is used. There's some heatsink compound inside the holes there. But hey, that's not too bad. They are available. So I can't do anything until I do that. The transistor, the diode itself, the 1N4004, right there. And so, let's see, right there. Yeah, so that's no big deal. Got plenty of those. Q03 goes to R31, which is 331. So this is supposed to be 15 ohms. And that is measuring 42 ohms. Let's lift an end of that. I mean, it can't be higher. I mean, this resistor's gone. What the heck? But it's definitely burnt. I got the manual. The only manual I could find was for the B version. And this is not a B version. Wow. That got seriously hot. Give it a little help here. Okay. Alright, what can we do to clean that up just a little bit? Yeah. That doesn't look good. I think it'll be okay, but it definitely doesn't look good. I could make a spot for it to go. Yeah, there's still enough pad there. I mean, it's a huge piece of pad. Goes right to that screw that goes right to ground. Or, well, whatever it considers to be ground. Is there a hole there? No. No. I'm just going to have to kind of tack it surface mounted on top of there. But there's plenty. Yeah. Alright, so I need a 15 ohm resistor. Oh. There's one. And I need a 4004. And a 4004. Okay. Got to be really careful putting these in because they can't go underneath at all. I mean, they're just long enough to go through the board, but not long enough to short out on the bottom, which is interesting. Do that okay? Yeah. Alright, so now we cut this off nice and short. Nice and short. Position over said holes. Yeah, let's clean the said holes first. Kind of fun working on this big old giant stuff after playing with surface mounts for so long. This stuff is relatively simple to work with, not that it's simple to fix. Okay. Okay. And now we got to play with this diode. Well, I know I can do it this way. On this end. Yeah, that'll work. It's not going to be factory pretty, but it'll work. Okay. Not much I can do about that actually burnt hole in the board. Fortunately, they are single-sided, all-surface mount. What do they call this? Dead bug style? The whole thing? Come on. Okay. So there's you. You're in there, you're on there, you're fine. Okay, so now all I got to do is get the 8281s. Oh, I didn't test these guys, did I? Let's see what these have to say. What are these? These are, well, this one is a C32988. No clue. I'm trying to be very careful with these legs because I do not want to break these off if they are glued to this board. So let's see what you think you are. It is a NPN transistor. It is BCE going from this side over. All right. And then there's this little guy down here, little bitty, sticking out of the board. Barely get any leads on. Don't want anybody to short together. Quit that. Okay. Let's see what this says. I can't move this where you can see it. Hang on. It's 2 diodes and a resistor. Okay, so I am shorted between 1 and 2 of myself, I think. That says it's a capacitor. Sorry about the top of my head. This may not be measurable by this device, but then I don't really know what it is either. It says it's a diode between 2 and 3. Okay. That is not. Well, it might be. Comes right off of R30. So R30 is going across one side of it and goes to this out here. So what does the manual say that thing is? Off the end of R30. So it'd be 3030. It is so hard to read. 33, 310, 329, 328. Okay, well, I did some measuring here, and it looks like this one here is measuring the same as this one over here. So whatever that is, I guess it's fine. I literally, I can't find it. I think I found R30. Where was it? Right here. But 30, 39, 40, and 314, they're not here. They're not on this board anywhere. So like I said, this is not the same board. It's close in some respects. So I guess since this one's measuring just like this one over here, we'll be okay. We got our little parts put in here. There isn't all the other parts. I mean, just go through real quick. They're all good. Everything else is fine. I got one bad transistor, but I guess I'm just going to order those parts off eBay and wait to get those in and put them in and bring this thing up slowly and see what happens. But it's all I can do for now. So I guess I'll be back. Okay, so we're back. It's been like almost 2 weeks, and I got the parts in. I got the new 8188-2s, and I got the other parts that go on the bottom of the board here and there. Those little parts I couldn't find. I finally took it out to see what it was and figured it out. That is a constant current source, that little guy. And it goes, show you over here, it goes right in here, in that little hole, right there. So, we were messing with, which guys was it? These guys down here over on this side. Yeah, that's the burnt side of that board. So we were messing with the 8180. Boy, I wish this... that's got one heck of a cord on it. Messing with these 8188-2s over here, and everything was okay. That little part I could not find is up here. It's right here. That little... Let's see, bring you down here. See if I can get you. Yeah. Little, yeah. Sticks through right there. And that is a little constant current source. There's one on both sides. There's one on the other side too. And it was bad, unfortunately. And so was... unfortunately, one of these guys back here. I went and checked them, and one of these guys was bad. Fortunately, that one is, let's see, those are the D6729 So I went back to the place where I got it before. I went to eBay. Seller KJ1960, KJ1960. Good prices, good fast shipper, and got them from him, and they were just fine. Put them in, everything. I did not have to replace the little temperature sensors, which are here and here. Remember, these are flipping around from each other. And I had to clean the pots back here, clean them up real good, because they were in terrible shape. I cleaned them the best I could. They're sealed, unfortunately. And there's some weird form factor I have never seen. So I just sprayed them until they finally gave up and came clean. They're about as clean as they're going to get. So I put it all in there. So let's see what happens now when I turn it on. So I've got it hooked up to the dim bulb tester. Turn it on here. And I've got an input going to the back on channel 1. And an output coming over here, going up to the speaker sitting over there. So let's turn it on. Yeah, boy, this thing is heavy. It's hard to hold up. Let's turn it on and see what happens. Ready? Clunk. Okay, those lights are supposed to come on until it comes on. And there it goes. The light's lit a little bit, but I do have audio. Yay! Fantastic. Let's take it off the dim bulb tester. And if I turn the thing up back here, I should be able to see that bottom light. Come on. There we go. I don't know. I'm going to see if I can find those pots, but if I can't, I don't know what I'm going to do, because they're definitely unobtainium. Anyhow, so this side works. The other side works too. I was lying to you. I wasn't lying to you. I checked it out before I turned the camera on, just so as not to be completely surprised. But it all works fine. I did set the bias down here. In order to set the bias, let's turn this off. set the bias, you take a voltmeter and you go across this resistor here, this R31, with the input shorted and no output, and you measure between 300 and 320 mils and adjust R26, which is this guy here, and then you put it across R32, which is a 22 ohm, I think, or 15. That's 15. These are both 15 ohms. And do the same thing and adjust R23 over here for 320 mils. And that'll give you the right balance. I did, when I got these parts, I got 4 of each of the transistors that go in here, and I did replace them both. I took them with with this thing, and matched them up for gain and front to back voltage, and glued these guys down too here, so back down. That was interesting, to say the least. Anyway, so I matched them up for front to back and for gain, so that they'll match. If you don't, you'll never get your bias set up right. You won't get it high enough or low enough. They're kind of wishy-washy in the book about it. It's 300 to 320. I got about 330, somewhere around there is the best I could do on this side, and 325, 330 on this side also. So the bias is set okay. This little connector back here that goes onto the board right here that's strapped on is actually a IC socket with a header going into it, and that thing got dirty really bad, and I had to pull it out and clean it and everything and make sure that it was okay. That's taken care of now too. So basically, what did we have? Well, we had this board look like it was burnt to ribbons back here, but the top isn't. That was just the smoke coming off of this diode. There's a diode under here, just like this one up here. All right, this is identical to this, so because they're flipped around. So on the other side, underneath this board, this diode was blown to smithereens, and it made the top board up here just charcoal black. I scraped it off the best I could. There's no resistance that I could find. This resistor over here was open. Yeah, it was open or shorted. I can't remember right now. But so I replaced that. These two 0.2 ohm resistors were just fine, thank goodness. And everything else was good out there on everything else. So all I had to do was replace the 2 transistors on this side originally, on the burnt side, and 2 transistors over here on this side for here, and the little constant current source, which is here, was bad. It wasn't working at all. So basically, there's my little pack of parts. I lost the resistor, but these guys are both of them are very low ohm resistors instead of transistors, and that diode just blew itself to hell when this thing shorted back here. Anyhow, so another different piece of equipment. Never worked on one of these before. It's nice. Like I said, I don't understand why they're using this to drive speakers in a room, just not even a studio, just a meeting room. That's a lot of power for a ceiling speaker, and they were doing it on 70 volts, which this thing will do 70 volts. So I checked these guys; they're good. Everything else is fine in here. It's just perfect. So anyhow, there we go. We got it. It's fixed. Put it back together again. Send it back, and the guy will be happy to have it back in the rack and working. As long as I can get that, I'm going to spray that a little bit more, see if I can do something about it, but I don't know. Like I said, they're pretty well sealed up. So anyhow, hey, thanks for watching. Sorry it was such a long one, but I thought it'd be fun to just go through one of these big old antique amps. Don't forget to go down there and push that sign up button and the bell so you know when I'm doing more of this stuff. Till next time.